Hello there, Mr. Chan here for Algebra 1. Let's get started here. Grab your student companions and turn to page 137. We're going to do a new section today. 7-1, adding and subtracting polynomials. Before we jump to actually polynomials, let's look at our opener here. Each year, the Student Council conducts a food drive. At the end of the drive, the members report on the items collected. As you can see from the picture here, we have oatmeal, peas, meat, beans, corn, and rice. Maybe we should just assign some variables here, like we normally would if it was a regular algebra problem. We have oatmeal. I count 1, 2, 3 bags of oatmeal. Use the letter O for oatmeal. Why not? We have some peas. 1, 2, 3, 4, 5, 6 peas. Kind of designating those variables. 3 cans of meat. 5 cans of beans. Inventory. 6 cans of corn. And 4 bags of rice. Nice. Question, describe 2 ways that the students can sort the items that were collected. I guess they're already sorted by item, so let's write that down. Maybe another way is to look at how they're packaged. And I take a look here, we have bags versus cans. That's a possibility. So let's write that down. Can versus bag food. This is sort by packaging. Right. So we can kind of see what's coming up with this particular section. It's about the type of items. In this case, we're going to look at variables 2 in a few moments. Write 2 expressions to represent the number and type of items collected. Earlier up there, we had, let me zoom out a little bit, those particular food items sorted by 3 bags of oatmeal plus 6 cans of peas plus 3 cans of meats plus 5 bags of, cans of beans plus 6 cans of corn plus 4 bags of rice. There we go, that works. At least all the variables are different from each other. We need another expression. Maybe perhaps we can look at cans versus bag food. We can use, let's do this. Let's count all the things that are bags. Let's do, oh look, oatmeal and rice. There's 3 and 4. 3 plus 4. And that's bags plus, let's count the cans, peas, meat, beans, corn, 6 plus 3 plus 5 plus 6 cans. I think I did it kind of backwards, no big deal. Which means that this is 7 bags plus 9, 14, 20 cans. That works, yeah. I guess I can use C's and B's or whatever. Hey, share your expression with classmates. How are the expressions similar? Okay, we can skip that. Question at the bottom, how does the structure of each expression relate the way you think about the items? Well, we do this as human beings. We order things and we sort items. All right, let's get started here. Next page. That wasn't too bad of an opener. All right, we have some vocabulary I do need to talk about here. Let's use some space off to the left and describe some terms here, starting with monomial. Write this down in the upper left-hand corner. A monomial, of course, is a polynomial with one term. It's a number, a variable, or product of numbers and variables, meaning a bunch of them together. Product means multiplication. And some examples. Oh, by the way, mono means one, of course. Quick example, some examples would be like the number 7. Oh yeah, let me put it underneath so it's easier. Oh, a variable, how about x? And maybe a product of a bunch of stuff, negative 3x squared y. That would be a product of numbers and variables. Awesome. Some more vocabulary. This particular section asks about the degree of a monomial. The degree is referring to the power. So the degree of a monomial is referring to the sum of the exponents of the variables of a monomial. The sum of the exponents of the variables of a monomial. That's very wordy. Quick example. I'm going to use those expressions up there. 7x and negative 3x squared y. The degree of the first one, which happens to be just a constant, is 0. Right? There's no variable, so you're assuming it's to the 0 power. Anything to the 0 power is 1. So technically, it's like saying 7x to the 0 power. That's just a quick show of how x to the 0 power is 1. It's kind of invisible there. How about x? The degree for x is just x to the first. Just the first power, it's right there. Just hiding right there. How about the next one? The degree for the next one is 3. Because there's a 3 right there, and there's an invisible one right there. 2 plus 1 is 3. Pretty easy. Okay. How about polynomials? What's a polynomial? A polynomial is the sum or difference of 2 or more monomials. Sum and difference means pluses and minuses, yeah? Yay. Separated by pluses and minuses. Some quick examples. 2x minus 3. It's called a binomial, by the way. Separated by plus minus sign. Bi means 2. Nice. How about this one? 3x squared plus 7x minus 5. Here we have a bunch of terms separated by pluses and minuses here. This is a trinomial. Tri means 3 terms. Okay. Ooh, we had a few moments ago something called the degree of a monomial. How about the degree of a polynomial? The degree of the polynomial is the highest amongst the degrees of the monomials. You pick the highest one of each of the individual monomials. Quick example here. What if we have 4x to the third minus 2x squared y squared plus 5 minus 6y? Each individually, the first one has a degree of 3, right? The second one has a degree of 2 plus 2 is 4. Nice. The third one has a degree of 0 because it's just a constant, right? And the last one has a degree of 1. So the biggest one amongst the 4 terms is 4. So that is the degree of that particular polynomial. Ooh. Then we have something called the standard form of a polynomial. It's what we prefer when you give an answer to us on a test or a homework. Standard form of a polynomial is referring to a polynomial that's in descending order by powers or degree. Descending means going down. Okay, decreasing, descending, same thing. And by degree, of course, we know as powers. Great. And usually when we do this, it's with only one type of variable, like an x, a y, but not both. Ooh. Something that you learned a while back. This is especially true if you're maybe when you're a kid, you're like going trick-or-treating and you want to sort your candy. You want to sort them by certain types. In this case, when it comes to polynomials, we want to combine like terms whenever possible. So let me sprinkle some things here after I give you a couple of rules. You want to do this with when it comes to adding and subtracting. And when you do this, you want to look for the terms with the same number of variables. Okay, the powers. Here, I'm going to just randomly throw some things around. See what we can do with this. All right, so I kind of threw like 8 terms up there. We want to see which ones are like terms that you can add and subtract. So one thing that pops out at me is the letter y. You guys see the letter y? Those are like terms, y and negative 4y. If I add them, you get negative 3. If I subtract them, I get negative 5 or positive 5, depending on which way you're going there. Do we have any z's here? No, we don't have any z's. We do have some x's. How about those? 1/5 x and 3x. Those can be added or subtracted, of course. And of course, we talked about z's, but how about x cubed? Are there any x cubed anywhere else? No. There's only one x cubed, so there's really no other term to combine it with. But we have some constants, 75 and 14/9. Those are constants. Those are like terms that can be added or subtracted. Okay. All right, let's go ahead and try some problems here after all this vocabulary. Thanks for being patient. Here we go. Number 1, name each polynomial based on its degree and number of terms. Right away, I see one term. Because it's one term, it's a monomial. The degree, if you think about it, is based off of the variables. Up here, I have a 1 plus 2, 1 for the x and 2 for the y. That is the degree. In this case, when you describe this particular monomial, it's a third degree monomial. That's how you say that, okay? Not too bad. How about the second one? The second one is a polynomial, and you want to look at each individual degrees here. We have actually 3 terms, by the way, because they're separated by pluses and minuses, right? So we know we have a trinomial, but what kind of a trinomial? Let's look at the powers. We have a 1 and a 1 there, so that is a degree of 2. We have a 1 here and a 1 there. The biggest one is the 1 plus 1, which is 2. And which means this particular polynomial is a second degree trinomial. Pretty easy. All right. Any questions? Number 2, write each polynomial in standard form. Standard form, of course, is rearranging the terms and put it in descending order. I'm looking at the first one, 2a, and I see that this particular one has 3 terms in it. That happens to be a degree of 0, then a 3 and a 2. So based off of that, I'm going to put it in this way. Negative 3x to the third plus 6x squared. I'm going down. Yay, that wasn't that bad. Okay. How about the next one? Oh, we have 3 terms here as well. Great. The first one is a degree of 1. Whereas, I forgot to mention x to the 0. This is 1. Oh, x to the 0 again. And 2. Let's put it in descending order from highest to lowest. The highest is negative 8y squared plus 2y minus 3. No way. Can't be that easy. Yes way. All right. Let's try number 3. Combine like terms. We're going to do some adding, subtracting. These are like rearranging your Snickers bars and M&Ms and your Laffy Taffy on Halloween night. So right now on number 3a, I see 4 terms. Terms are separated by pluses and minuses. Okay, there they are. There are 4 of them. Let me see. Let's go from left to right. Are there any x squares? Oh yeah. Here's an x squared, there's an x squared. 4x squared minus 1x squared, there's an invisible 1 there, that's a coefficient, yeah? 1 minus 4 is 3x squared, so those are done. Next one, negative 3x plus 3x. Oh, that's interesting, they 0 out. So what, that's it, that's the only one. That's the only answer for that. Easy. Letter B. There are 5 terms separated by pluses and minuses. Let's go from left to right. Oh, look, we have some y cubes. 7 of those plus 5 of those is 12y cubed. Nice. Are there any y's? Let's take a look at that one. Oh, look, negative 3y minus 2y is negative 5y. Nice. And then finally, we have a 7 by itself on the very, very end. Let's just bring that down for itself, by itself. And that's it. Yeah, that's it. I think we're ready for the next page. I'm going to skip the habits of mind there. Not too bad. This is swimmingly going fast. Hey. Number 4. Oh, we're just adding a bunch of polynomials together. When you're adding, you can just pretend the parentheses aren't even there. Okay, it's not a big deal. Pretend the parentheses for 4a and 4b are not there. Let's combine my terms here. Are there any x squares anywhere? Nope. There aren't any x squares, so that's by itself. How about x's? 2x plus negative x, that's like negative 1x. What's 2 minus 1 is? Oh, that's 1x. Nice. And then finally, the 9's by itself. And there's your answer. Yay. For number 4a. 4b, let's combine like terms again. Any x squares anywhere? No, kind of boring there. How about x's are next? 5x plus 3x is 8x. Nice. And then finally on the end, we have negative 7 plus 7. They go away. That's 0, which means we don't even have to write it. There's your answer for letter 4b. Let's go to subtraction. Subtraction is a little different where you have to worry about the minus sign in front of the second parentheses, right? So in your mind's eye, you should probably distribute it like this and rewrite the whole thing for both of them. It's just easier, trust me. And from there, you treat it like an addition problem. Now watch this. Minus minus becomes plus x. Minus positive is minus 4 for the first one. Let's look for like terms. Any x squares? Nope, that's the only one right there. How about x's? I have 4x and 1x is 5x. Easy, easy. And then finally, the constants 2 plus negative 4 is minus 2. And that's your answer for number 5a. Let's distribute the 5b one. First half stays the same, minus 4x squared. Oh, watch out there, minus 6. I like to go from highest to lowest power. X squares are first. I don't see any other x squares, so that's first. How about x's? Oh yeah, minus 5x is next. And the constants, I see a negative 6 and a negative 6. That's negative 12. Right? You owe somebody $6, you owe another $6, that's $12. Yay! Skipping number 6. And hey, habits of mind. A student claims that the difference of the expression blah 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 is 0. Is the student correct? Let's see what happens and see what if it works or not. So let's rewrite this. Minus 3x squared minus 5x plus 2. Oh, that's kind of weird. I think, yeah, this doesn't work. Bring up the first half down. See, the 3x's go away, 5x's go away, but I think those are tight. Yeah, that part and that part, nope, doesn't equal to 0. So the answer is no, not correct. All right. I don't know about you. I'm ready for the last page. Here we go. Yay. Not too bad. Number 6. Do you know how? Name each polynomial based on its degree and number of terms. Now, the number of terms here for number 6 looks like a binomial. What kind of a binomial? Binomial means 2. And in terms of degrees, I see there's an x to the first power. So this is a first degree binomial. That's all it is. That's it. First degree binomial. How about the second one? Second one, I see 3 terms. So this is definitely a trinomial. Okay, what's the degree? I see a 3 there and a 1 and a 1, which is 2 and a 0 over there. So the biggest one is 3. This is the third degree. Trinomial. Nice. Hey, let's do number 8 and 9 and put it in standard form. Highest to lowest. I see 3 terms for number 8. Negative y squared is first. Then 2y. Watch out for the signs. Keep those in front of them, right? And then minus 3. That was not bad. Highest to lowest. I see 3 terms in number 9. I see a 3 and a 2 and a 1 and a 0. Let's put that in order. Let's do it. So we have x to the third plus 3x squared minus 2x plus 6. That was not bad. Nice. Ooh, let's add for number 10. Pretend the parentheses aren't even there. Any x squares? Oh yeah, we have 1x squared plus, because that's an invisible 1 right there. 2x squared is 3x squared. Nice. Then we have the 2x's. Oh, 2x minus 5x is negative 3x. Nice. And then the constant by themselves, negative 4 plus negative 3 is negative 7. And that's your final answer for number 10. Number 11 I can't do until I distribute the negative sign because it's easier for me, and then rewrite the whole thing. I have plus 4x squared plus 2x plus, wow, everything's plus there. Bring all these guys down as well. And let's just apply this problem like we did in the previous one. X squares, yep. 3 and 4 of those gives me 7x squares. Then we have a negative 5x and a 2x, negative 5 plus 2 is negative 3x, and then a constant by itself, negative 8 plus 1 is minus 7. And ladies and gentlemen, we were able to finish this in under 30 minutes. How wonderful is that? Thank you very much. I'll see you next time. Bye-bye.